right, so today we're going to talk about the harmonic series. And a harmonic series is one important series that comes up, obviously, throughout mathematics, especially when we're talking about wavelengths. Now, the harmonic series, as you can see here in the first little thing, I'm going to make it bigger here, looks like this. And it starts with 1, and then it has 1/2, 1/3, 1/4, 1/5, and you can expect it to continue in that pattern, 1/6, 1/7, and so forth. And what we learn is that it equals infinity. And the first thing I want to do today is show you why it actually equals infinity, or at least how we know it does. And notice some other patterns within the harmonic series, because there's many patterns within here, and we're going to use that as we move forward. And so that picks up tomorrow. The harmonic series starts with 1, and that's kind of obvious. So we have 1 here. I'm going to separate that. And then we have 1/2. If you look, by adding the next 2 fractions, now stay with me here, 1/3 plus 1/4, if you follow this thinking here, together they are actually greater than 1/2, because 1/4 plus 1/4 would be 1/2, correct? And 1/3 we know is bigger than 1/4, so therefore the 2 fractions here combined, we don't need an exact, but we know that it's greater than 1/4. Now as you look at the next one, 1/5, 1/6, 1/7, and 1/8, we get another grouping that is actually greater than 1/2. Similar to the argument that we had with 1/4, we would have 1/8 plus 1/8 plus 1/8 plus 1/8 would give me 4/8 or 1/2. But we know that 1/5 and 1/6 and 1/7 are all greater than 1/2. So if we were to add those 4 fractions together, it actually equals 1/2 or greater than that. So far we have 1, we have a 1/2, we have another 1/2 and another 1/2. And what you're going to notice is this pattern continues. You'll notice that it only took 1 fraction here with a 1/2. Then it took 2 fractions for the next grouping of a 1/2. It took 4 for the next grouping of a 1/2. How many do you think it would take for the next 1/2? My hope is that you said 8, because it does. It's 1, 2, 3, 4, 5, 6, 7, 8. If we were to add up these and pretend almost as if they were each a 16th, which is the smallest value that it would be, that would be 8/16, right? Which is greater than, again, 1/2. So if we notice, okay, here we have 1 term, right? Here we have 2 terms. Here we have 4 terms. Here we have 8 terms. The next would be 16. The next would be 32, then 64. And even though it would take a great amount of terms to get there, do you see that each of those groupings are going to give me another 1/2? So it's like adding a 1/2, a 1/2, a 1/2, a 1/2, a 1/2. It's not changing in dimension. We're actually just keep adding 1/2, something that is greater than 1/2. So it, in fact, continues to just keep growing and growing and growing and growing. And so that is one of the ways that we know. Now, how this is actually applied is when you look at series like you see here, you have 1/7, 1/14, 1/21, and 1/28, and so on. We want to say to look for the pattern. And when you look for the pattern, it's not that, and this is where it's important. You might say, oh, I could multiply by 1/2, but can you multiply by 1/2 to get to the next one? And of course the answer is no. So we know that this is not the same kind of converging series that we've seen in the past. In fact, this is an example of a harmonic series. Let me show you how that works. If I took out 1/7, can you see that all of these denominators are a multiple of 7? I would have, as the first term would be 1, the second term would be 1/2, the next would be 1/3, the next would be 1/4, and of course the others would be just as obvious. Again, we understand this to be the harmonic series, and we now know, just from the previous slide, that the harmonic series actually equals infinity. So therefore I have 1/7 times infinity, and as we learned in last chapter, that doesn't make much difference. It's still infinity. So I want you to notice an important piece of this. How can I tell the difference between a converging series and a harmonic series, or a diverging series and a harmonic series? Let's just take a check at this one. The pattern that we see here is that we're multiplying by 1/2. So we need to ask ourselves, do we do the same thing to get to the next one? And of course, yes, we do. And so what that tells me then is all right, this is converging, so I'm going to set it equal to S. I'm going to use the pattern of 1/2 S and recognize that what I'm going to get is all those subsequent terms, not the first one, but just everything after that. When I subtract, they all go away. I'm left with just that first term, and I have 1 minus 1/2, which of course gives me 1/2 S. I keep changing flip, and so I'd have S equals 2 over 4, which of course is 1/2. And that would be my final answer for that series. Whereas the next one, we might say, okay, we can multiply by 1/2 for that, but can we multiply 1/2 to get to the next term? And the answer is no, we can't. So we go back to the drawing board, and we notice, though, that each of the denominators are a multiple of 4. Unlike what you see up here at the top, yes, they're multiples of 4, but it doesn't go in the order of 4, 8, 12, 16, 20, right? That's what we'd expect the next bottom to be. In other words, what's happening to go in between here is we're not multiplying, but rather we're adding. And by seeing that it's an adding, it's a multiple, right? Not a power, but a multiple. Then what we can do instead is recognize the harmonic series. Again, as I showed you in the previous example there, you take the 1/4 and you pull it out. You would be left with a 1, 1/2, 1/3, 1/4, and so on. Just to once again prove it to you, if I pull the 1/4 out of this one, I again would have 1, I'd have 1/2, and then I would have 1/4, and then I would have 1/8, and we could keep going. Again, you notice the multiple that's going on here. See the 2, 3, 4, you can recognize the harmonic series. So once again, this would be 1/4 times infinity, which tells me that's in fact infinity. So when we come across that harmonic series, it's easier to tell because of the harmonic series being rather almost like addition in between them, not multiplication, and that is a big clue.